Hello everyone, I hope you're doing well. Welcome to the third video in the series. In this video, we're going to be covering introductory data preprocessing. Now, as you'd recall from the previous video, we've covered what pandas is and some basic operations with it. In this video, we're going to understand how pandas can be used to preprocess data. Now, for any machine learning model you build, if you want it to be successful, you need to correctly preprocess data so that the Python ML libraries, say scikit-learn, keras, they're able to properly interpret and work with the data. Now, say you want to work with natural language processors. You'd need to convert categorical data into numerical data. You can use, say, one-hot encoding, TF-IDF vectorizers. Basically, the idea is that Python can understand the data it is working with. Now, the first aspect of preprocessing is data cleaning. This can often seem like a menial and tedious task while you're doing it, but in the long run, it's very important, especially when you're working with large data sets. What cleaning entails kind of differs from data set to data set, from situation to situation. The idea is that your data frame, or whatever data set you're working with, can be understood easily by the Python ML library. So some simple yet important concepts in data cleaning, like data separation, renaming columns, removing duplicates and null values. Sometimes you can use regex to remove annoying characters in the middle of data and so on. The list is really endless, but let's go over some of these basic ideas. Okay, so diving right in, let's use the Titanic data set. Now, as you can see, we have the Titanic data set here. Now, if we want to perform certain functions with it, we'd have to first clean the data set. Well, I'll be fair, the Titanic data set looks fairly clean already, but well, there's always room for improvement. Now, as you can see, I've performed a number of functions here with the Titanic dataset, and these are just some examples of what we can do in data cleaning. So I'll quickly go through them. Now, say you want to rename the columns in the Titanic dataset. You can simply use the rename function, entering the old and new column names as a dictionary. Now, as you can see here, I've changed the name from passenger ID to passenger ID here, and this can be reflected here. Similarly, I've changed it from P class to passenger class, and the same can be reflected here. Now, say you wanted to set the index of the data frame to be a certain column. Now, the default index of a data frame, as you can see here, is from 0 to a specific number. So, say I set the passenger ID to be the index of the data frame, and here you go. The passenger ID is being used as a data frame index. Say I want to sort the values of the data frame using a specific column. In this case, I've used the passenger class. So 1, 2, and 3 would be it in ascending order. Now, as you can see here, I've used ascending equals to true. Now, ascending equals to true is also the default value for ascending. However, say you wanted to have 3, 2, and then 1 as in descending order, you could just set ascending equals to false. Now, similarly, say I want to find the average age of the members in the Titanic. If I were to compute it, pandas would automatically interpret all the NaN values to be 0. Well, they may not always be. So say you have so many NaN values throughout this data set. So for example, here you can see in the age column, you have an NaN value. And if I were to compute the average, pandas would automatically take this to be 0.0 when it may not be. So we have a solution for that. Here you can replace the NaN values with 0.0, as you can see I've done here. And what we can also do is that you could count the number of such occurrences, so you could subtract that from the number of columns when estimating the average age. Now, here I've used the number 891, and I'm pretty sure all of y'all are wondering why I've used that number. It's because I know for a fact that there are 891 rows in this data set. But if you were to find the columns and number of columns and number of rows respectively, you could use the functions mentioned here. Now, like I said before, this is just a few ideas that you could use in data cleaning, but there's a bunch of stuff you could do, like, I don't know, removing quotation marks using regular expressions, etc. But all of that slightly falls outside our scope, so we'll stick to this for now, but be sure to check out the Pandas API for more. Right, so now let's try and understand the next concept, data normalization. Here the goal is simply to change numeric values in a data set to a common scale without actually distorting the differences in the range of values. Machine learning models are a little wacky when you're working with large ranges, so normalizing the data really helps better model it. Now, there are several types of normalizers, but due to paucity of time, I'll just be covering the details of one and explaining how a couple work, and I'll be giving you like the API, etc., to figure out a few on your own. Now, each of them is found in the sklearn.preprocessing library. What we'll be working with is the standard scaler which supports normal distribution. Now, for example, if I were to graph something, approximately 68% of values would fall between -1 and 1, which both represent the standard deviation points. Okay, so I'll just take you over some basic standard scaling. You can see we're working with a very small data set just to make you understand the basic idea of what standard scaling is. And always note that the input here has to be a two-dimensional data set because that's how the standard scaler works. Now, what exactly it does is that you see these values of 100, 850, etc. It scales them down and makes them, you can see here, the values of a -1 to 1 scale. Now, basically, when you have your standard scaler, you can define a scalar equals standard scalar, and then use a fit underscore transform function to just work with the data. It's as simple as that. Now, some people prefer using the fit and transform function separately. You can do that. Just check out the exact syntax for that. But personally, I find this a little easier. So what exactly is happening can be seen here. I've just plotted it out just to make it a little easier for you to understand. Now, obviously, you are probably wondering why this doesn't conform to the typical normal distribution curve that you've seen all this while. And the reason is we only have 5 data points. If we had like a cluster of data points, it would much better conform to the normal distribution curve. But the idea is here that you have -1, which represents one side of the standard deviation, and 1 which represents another side of the standard deviation. This point here is the closest to the mean, and these points are outside the first standard deviation. So essentially 68% of this would be outside the first standard deviation, right? Just now to get you a little bit accustomed with other scalars, we have the min-max scalar, which stores data values between a certain range. So usually use 0 to 1, but you can basically use anything else. The minimum value gets transformed to the lower range, which would be say 0, and the maximum value gets transformed to 1, which would be the higher range. We also have the robust scalar, which essentially works with sparse data sets. It'll remove the median of the data set and work with interquartile ranges. Now, all of these data scalars have a ton of additional functionality, which again, we are unable to cover in depth due to paucity of time, but do check out the API, and there's a lot to see how you can like manipulate data and work with your machine learning model. I think the main idea here is that you need to understand what your machine learning model or whatever model you're creating requires, and accordingly work to normalize, scale, or do whatever with the data you need. So also remember that there are some cases in documentation where you've seen that the standard scalar is quote unquote set to standardize data and not normalize it since it isn't putting it within two certain bounds. So just keep that in mind for future. Right. So the next thing that we're going to be covering is feature engineering and manipulation. Now, as you can see here, we've printed out the head, which is the first 5 rows of the data frame. Now, say we use the function df.iloc2. Now, what exactly does this mean? It simply returns a single row, which we also call a series. And as you probably remember from using Python or pretty much any other language, it always follows zero indexing, which means that everything starts on the 0th index. So, for example, since we've printed iloc2, it would print the 3rd row in the data frame, which is this one. So you can look at it here as well. You can see survive, passenger class, etc. Everything points to Miss Laura Mabel Francatelli, right? Now, similarly, if we want to print out a specific value in the row, like a specific column and a specific row, we can use the .iloc function and put 2 parameters, which would be the row followed by the column. We can similarly use the assignment operator to even change values in this row and column, and we can use the iloc function just to get the value and the at function to actually change the value, as you can see here. So here what we've done is we've multiplied the age by a factor of 1.25, and you can see 30.0 and 47.5. Similarly, you're also capable of editing columns. So if we want a constant value to run throughout a column, we can just put a constant value. For example, you can see a new column chosen value equals 2. And here, as you can see, you have the column value is 2. We can have another random value. So you just call np.random.rand. It just generates a random value from 0 to 1. So this column has, I don't know, random values like this. And what you can also do is you can take an existing row and do something with it. So in this case, we've done something very simple and just added a value of 1 to the existing df fare column and made a more expensive fare column. But similarly, you can make a bunch of things with this. Like you can take df fare column and, I don't know, divide it by 3, you can multiply it, etc. So when you're actually modeling different things, it's very helpful to be able to change around columns a little. It saves a lot of time from actually having to recreate the column from scratch. Right. So now these are very effective methods when you're working with numerical data sets. There often are instances when you have to work with categorical data, which means you need to convert it into numerical data for Python ML libraries to understand. Now, this often happens when you're working with natural language processing. So there's a few techniques you can use here. There's TF, IDF vectorizers, labeling, coding, etc. But my personal favorite is one-hot encoding. So let's dive a bit into that. Now, these are a little more complex in terms of syntax, especially, as you can probably see in the code I'm sharing. But do pay close attention because it is very, very helpful. Now, say we had three terms, okay? Red, green, and blue. You can always represent this as a 3 by 3 matrix with ones on the diagonal. Now, if you've done linear algebra, I'm sure you'd have come across the concept of row-reduced matrices, and it's something along those lines. Hey, don't worry if you haven't though, the math behind it isn't too important for coding. So let's look at some code around it. Say you have this sentence here, I'm a rambling wreck from Georgia Tech. Now, let's define a universe of possible values in the sentence. So I've done that here. It's all the letters of the alphabet and the spacebar. So, obviously, when you're using more complex models, there's a lot more to consider in terms of variables. But what I'm trying to do here is explain the basic concept, and you're always free to check the API, Stack Overflow, ask as many questions as you want, whatever you want, basically. So, in this simple line of text, you can see all the characters from A to Z in a spaced character, like I said. Now, using the enumerate function, we can convert each of these characters into numbers from 0 to 25, representing indices of these letters. Yeah, that's one-hot encoding. It's as simple as that. And this code does look a little complex, but if you try to deep dive into it, pause the video for a second and just try and understand what exactly is happening here. Other than a few syntactical things, it isn't too difficult. Now, it's a lot to take in. Once you get the hang of it though, it's super, super fun to work with. And if you're a little bit geeky, well, I'm definitely guilty on that charge, do check out the math behind one-hot encoding too. It's a really, really interesting read. Right, so that brings us to the end of the video. And I hope after hearing this, you have a fair understanding of the importance of data preprocessing. Here we've covered data cleaning concepts such as renaming columns, removing and replacing null values, etc., creating data frames from existing ones, basic normalization techniques such as the standard scaler, the min-max scaler, and the robust scaler, feature engineering and manipulation, as well as a small dive into one-hot encoding to convert categorical data into numerical data. I really hope you enjoyed this video, and please do feel free to check out the API for more and ask us as many questions about any of these topics. And, well, let your imagination run. There's a lot you can do with data preprocessing, and it's a lot of fun.